The climate on Mars was once warm enough for potentially habitable lakes and rivers of water to exist. However, about 3.6 billion years ago, the climate changed from habitable to inhabitable when liquid water vanished from the surface. Welcome to the CHF Information Channel. Before we begin, please remember to like and subscribe if you enjoy our video efforts. Because of the planet's proximity and similarities to Earth, the possibility of life on Mars has piqued the interest of astrobiologists. To date, no evidence of past or present life on Mars has been discovered. The accumulation of evidence suggests that the surface environment of Mars had liquid water during the ancient Noachian time period and may have been habitable for microorganisms, but habitable conditions do not always indicate life. Scientific searches for signs of life began in the 19th century and are still ongoing today through telescopic investigations and deployed probes. While early work was phenomenological and bordered on fantasy, modern scientific inquiry has focused on the search for water, chemical biosignatures in soil and rocks at the planet's surface, and biomarker gases in the atmosphere. Because of its resemblance to the early Earth, Mars is of particular interest for the study of life's origins. This is especially true given Mars' cold climate and lack of plate tectonics or continental drift, resulting in a planet that has remained almost unchanged since the end of the Hesperian period. At least two-thirds of Mars' surface is more than 3.5 billion years old, and Mars may thus have the best record of the prebiotic conditions that led to life, even if life does not or has never existed there, which could have begun as early as 4.48 billion years ago. Following the confirmation of the past existence of surface liquid water, the Curiosity, Perseverance, and Opportunity rovers began searching for evidence of past life, including a past biosphere based on autotrophic, chemotrophic, or chemolith-autotrophic microorganisms, as well as ancient water, including potentially habitable fluvio-lacustrine environments, plains related to ancient rivers or lakes. The search for evidence of habitability, taphonomy, the study of fossils, and organic compounds on Mars is now a top priority for NASA and ESA. Organic compounds discovered inside sedimentary rocks and boron discovered on Mars are of interest because they are precursors for prebiotic chemistry. These findings, along with previous evidence that liquid water existed on ancient Mars, lend credence to Gale crater's possible early habitability. Mars' surface is currently being bombarded with ionizing radiation, and the Martian soil is rich in perchlorates, which are toxic to microorganisms. As a result, the general consensus is that if life exists, or ever existed, on Mars, it can be found or is best preserved in the subsurface, away from the harsh surface processes. NASA announced in June 2018 the discovery of seasonal variations in methane levels on Mars. Methane can be produced by microorganisms or geological processes. The European ExoMars Trace Gas Orbiter began mapping atmospheric methane in April 2018, and the 2022 ExoMars rover Rosalind Franklin was scheduled to drill and analyze subsurface samples before the program's indefinite suspension, while the NASA Mars 2020 rover Perseverance, which successfully landed, will cache dozens of drill samples for possible transport to Earth laboratories in the late 2020s or 2030s. An updated status of studies involving the possible detection of life forms on Venus, via phosphine, and Mars, via methane, was reported on February 8, 2021. Scientists do not know the bare minimum of parameters required to determine habitability potential, but they are confident that it is greater than one or two of the factors. Similarly, the habitability threshold for each group of parameters must be determined. Laboratory simulations show that when multiple lethal factors are combined, survival rates drop dramatically. There have yet to be published full Mars simulations that include all of the biocidal factors. Furthermore, the possibility of Martian life having biochemistry and habitability requirements that differ greatly from those of the terrestrial biosphere is an open question. That's all for now. Please subscribe to our channel and press the bell button to receive notifications about new videos.